Get ready to witness the impossible. China is changing the construction landscape, pushing boundaries with megaprojects that leave engineers worldwide in awe. Think colossal dams that generate record-breaking amounts of electricity, tunnels built through impossibly tricky terrain, and bridges that make you feel like you're walking on air. These projects aren't just big, they're fast, and discover the ingenuity that shapes some of China's most insane megaprojects, that turns blueprints into reality with astonishing efficiency. But how does China do it? What secrets lie behind? China is known for constructing massive highways, sprawling bridges, and sleek high-speed rail lines at mind-blowing speeds. Advanced technology, cutting-edge construction methods, and an unwavering determination fuel this relentless pace. He's engineer, apparently. Behold the Sanyuan Bridge Replacement Project, city's busiest highway artery, choked with traffic day and night. Now, imagine the bridge at the heart of this network suddenly becomes dangerous. Traffic can't stop, not for months. It's a logistical nightmare, unless you completely shut down the bridge. What follows is a symphony of cranes, precision technology, and raw power. The old bridge has to come down and fast. First, the Sanyuan Bridge is old, and the traffic load is unbearable. It's literally sagging under the weight. This bridge carries over 200,000 vehicles a day. Nope, not an option. So here's the plan the Chinese came up with. Picture first order of business, cut that thing to pieces. Saws slice through concrete and steel, breaking the old bridge into 27 giant chunks. The heaviest weighs about 139 tons. That's nearly twice the weight of a blue whale. Now, the tricky part. This demolition takes place while the old bridge is still partially standing. If we mess this up, the whole thing could collapse. Each of these gigantic chunks has to be lifted off by massive cranes, careful not to disturb the rest of the teetering structure. Talk about high-stakes Jenga. But here's where it gets truly wild. While this demolition ballet is happening, the new bridge is nearby. It's massive, nearly 1,300 tons, fully assembled. How do you move something so big so quickly? Enter the Shen Tuo. Two monstrous Chinese-made up because if a bridge rebuild in 43 hours impressed you, China's high-speed rail network boasts an even more mind-bending feat, constructing a functional train station in a mere 9 hours. Let's dissect this engineering marvel and see how they pulled it off. First, some context. This wasn't a brand new station sprouting from scratch. The project involved upgrading a crucial section of track near the existing Longyan Station, a bustling hub in Fujian Province. The goal? To seamlessly integrate the station with a brand new high-speed rail line. Imagine the impact. Journeys that once took 7 hours would be slashed to a breezy 90 minutes thanks to these sleek bullet trains zooming at 200 kilometers per hour. Now, here's where the 9-hour magic happens. The key lies in meticulous planning and a heavy dose of prefabrication. Months before the big night, engineers meticulously mapped out every step of the process. Think of it like a high-stakes chess game, where every move needs to be calculated in advance. Prefabrication became their secret weapon. Instead of painstakingly laying the track on site, pre-assembled sections, complete with sleepers and ballast, were cast off-site in dedicated facilities. Imagine giant Lego pieces for a high-speed railway. The big night arrives, and 1,500 workers descend upon the site with military precision. Time is of the essence. Disrupting a major station like Longyan for an extended period would cripple the city's transportation network. So they work through the night. A well-oiled machine divided into specialized teams has been built in a mere 9 hours. If you thought a 9-hour train station was impressive, buckle up. China took on a maritime challenge of epic proportions, designing and constructing the world's longest sea crossing, the Hong Kong-Zhuhai-Macau Bridge. This behemoth, stretching a mind-boggling 55 kilometers across the Pearl River estuary, isn't just about convenience. It's a linchpin in China's ambitious plan to transform the Greater Bay Area, a network of 11 cities, into an economic powerhouse. Here's where engineering ingenuity meets ambition. This wasn't a simple bridge build. Picture the challenges: frenetic shipping traffic, the wrath of typhoons, and delicate marine ecosystems, particularly those of the iconic Chinese white dolphins. Another megaproject that reshapes our understanding of renewable power. This beast of a power plant boasts an installed capacity of 16,000 megawatts, capable of generating over 62 billion kilowatt hours of electricity annually. But the real story lies in the engineering feats behind its construction. Let's start with the heart: the turbines. Beihetan breaks records by sporting 16 gargantuan 1,000 megawatt hydroelectric turbines, the largest ever built. Forget numerous smaller turbines. This approach means lower installation costs, reduced maintenance, and a jaw-dropping energy conversion efficiency of 96.97%. But how did they pull off designing and building such behemoths? Deep within each turbine, a complex water guide mechanism dictates the incoming flow of water. It's a critical comprising water leakage around moving parts. They've slashed theoretical leakage levels to a mere tenth of what's typical for such massive turbines. This ingenuity directly translates to greater power output. Now, let's venture outside the turbines. The force these machines generate is held back by a colossal 289-meter concrete arch dam, the height of a 100-story skyscraper. This isn't just about keeping a lake in place. This structure withstands an unimaginable hydraulic force of 16.5 million tons. It's meticulously engineered to function safely under extreme floods and earthquakes. To control water flow under emergency conditions, a massive quick energy gate relies on the world's biggest hydraulic hoist. This beastly cylinder, with its ceramic-coated piston, can lift the equivalent of 800 cars. Inside, SKF's specialized spherical bearings ensure smooth operation and exceptional load-bearing capacity despite the harsh, humid environment. But it's not just brute force, it's about precision. SKF's sealing technology keeps this hoist functioning flawlessly, preventing hydraulic fluid leaks and protecting internal components. Specialized materials with anti-friction and anti-creep properties are vital for long-term reliability under the relentless pressures of this environment. The Beihetan hydropower station isn't just a source of clean energy, it's a disruption. And preserve those dolphin habitats, engineers opted for slender, single-column piers anchored deep into the seabed. Above the waves, 3 cable-stayed bridges, each with unique, sail-like towers, rise to support the massive carriageways. It's an aesthetic statement as much as an engineering achievement. Now, about those artificial islands. These aren't just mounds of sand dumped into the sea. They've meticulously engineered structures crucial to the bridge's functionality. They seamlessly transition traffic from colossal bridges to a 6-kilometer-long underwater tunnel. Think of them as giant traffic interchanges in the middle of the ocean. Speaking of underwater tunnels, this project features one of the most complex ever built. Instead of boring through solid ground, it's made of 33 massive concrete sections, each weighing a staggering 80,000 tons. These sections were carefully lowered into place, forming a massive underwater highway. It's a testament to the precision and power of Chinese marine engineering. And let's not forget the logistics behind this mega project. Coordinating massive construction teams, specialized machinery, and the movement of building materials across land and sea over a 9-year construction period is a ballet of planning and problem solving. The result? A journey that used to take hours by ferry now takes a mere 40 minutes by car. The ripple effects are huge: increased trade, a boost to the tourism industry, and the symbolic binding. Let's shift gears entirely and focus on the lightning-fast construction of a medical marvel, the Huoshenshan Hospital, built in Wuhan, China, in a staggering 10 days. Imagine battling a rapidly spreading virus with limited healthcare resources. That's exactly the situation Wuhan faced at the beginning of the COVID-19 pandemic. To effectively isolate and treat patients, the need for a dedicated medical facility arose with unparalleled urgency. The Huoshenshan Hospital wasn't built from scratch. It was strategically constructed on the pre-existing logistics site. This smart choice saved precious time on land acquisition and initial groundwork. However, the real marvel lies in how they transformed this empty site into a fully functional hospital in a mere 10 days. The answer lies in prefabrication, a construction technique where key building components are manufactured off-site under controlled conditions. Think of Lego blocks, but for hospitals. Prefabricated walls achieve this rapid construction. A staggering workforce of over 7,000 skilled laborers worked around the clock. Imagine a well-oiled machine, electricians installing pre-wired panels, while plumbers connected pre-assembled units. This coordinated effort ensured minimal delays and maximized efficiency. Here's where the numbers become truly staggering. The hospital sprawls across 34,000 square meters, boasting 1,000 patient beds spread across 2 floors. To achieve this in 10 days, workers laid an average of 2,500 square meters of prefabricated panels every single day. That's the equivalent of building a new house every few hours. But how exactly did these pre-assembly process? The Huoshenshan Hospital wasn't just about speed, it was about functionality. Dedicated isolation wards with negative pressure ventilation systems prevented the spread of the virus within the hospital. Advanced medical equipment, including respiratory machines and diagnostic tools. China stepped into the African spotlight in 2003 when it began construction on the Meru Dam, a behemoth aiming to be the largest contemporary hydropower stretches across the Nile River in Sudan, roughly 350 kilometers long, harnessing the Nile's mighty flow to kilometers long. The dam's sheer scale is enough to steal your breath. That's taller than a 20-story building. But the dam isn't a single uniform structure. To maximize efficiency and stability, the lies in the left river channel, where an 883-meter-long earth-core rock-filled dam stands compacted to form an only line of defense, though. Flanking the earth core dam, stretching 4.3 kilometers, Banks Dam isn't far behind. They need to control its flow for power generation. A network of sluices allow for controlled water. Meter-long spillway ensures safety by providing an overflow channel during period. Is the 300-meter power intake dam, which houses the Meru Dam. Boasts 10 125-megawatt designed to handle a flow rate of 300 cubic meters of water per second. Giant water wheels, each spinning with the force of a rate of 5 terawatt hours annually. Dan's vast network, a massive grid, was undertaken alongside the dam, laying over 1,500 kilometers of new transmission across the Bayuda Desert to reach Atbara, while others head west along the Nile. As an infrastructure powerhouse comes from its boldness, a willingness to tackle projects that others deem impossible. One such challenge was the Humeling Tunnel in Gansu Province, labeled the most difficult tunnel to build. A mere 173 meters of this tunnel left engineers worldwide stumped, even after Germany, a nation renowned for its engineering, persevered. And after 6 long years, the seemingly impossible tunnel was finally completed. Tunnel so uniquely problematic. It all boils down to geology and location. This tunnel wasn't just cutting through solid rock. Its path crossed the loess, a notoriously loose and unstable material that tends to liquefy when disturbed. Cracks appear, threatening to collapse the entire structure. To make matters worse, heavy rains would further destabilize the ground, potentially leading to its frustratingly fragile nature. But China wasn't about to give up. Determined engineers devised a daring plan, combining 100 workers toiled in shifts to overcome the challenges. Progress was painfully slow, averaging a mere 2 to 3 meters per day. The harsh climate added further hurdles. In icy winters, an entire team was dedicated to ice-breaking sea river basins. Its economic impact ripples across the region, boosting trade and tourism along its route. Picture the mighty Yangtze River, once a force of nature, carving its way through the breathtaking Chongqing, Wu, and Shi. Vision became a reality with the construction of the Three Gorges Dam, an engineering marvel that stands as the world's largest hydroelectric project. This dam is nothing short of colossal. It spans a mind-boggling 2,335 meters across the river and towers cubic meters of concrete, enough to fill thousands of Olympic pools, and integrated 463,000 metric tons unlock the river's potential. The dam's construction flooded the three scenic gorges, creating a new deep-water highway allows massive ocean-going freighters to sail over 2,000 kilometers all the way to the bustling city. Logistics required to navigate this massive of lifting and lowering vessels weighing up to 10,000 tons. Smaller ships seeking faster transit, there's an even more incredible feat of engineering: the world's largest ship lift. This colossal elevator for boats bypass its megaprojects are built on a foundation of audacity and glass. Have you ever dreamed of walking on air? Picture yourself China's Zhangjiajie Glass Bridge, the world's longest and highest glass-bottomed pedestrian bridge. Vision and perception, creating an illusion of weightlessness that will leave you in awe. Stretching 375 meters, filled with reinforced concrete, 2,200 tons, a reassuring heft for those who dare to tread on its glassy surface, on roughly 48 million pounds, in ensuring both its beauty and its safety. The true magic of the bridge lies in its glass deck. It's constructed from a triple layer of specially hardened glass, each layer a substantial 50 millimeters thick. This isn't the kind of glass that shatters at the slightest tap. To prove its resilience, engineers can walk. Bungee jumpers can now plunge towards the canyon below, adding an extra layer of adrenaline to the experience. But what makes this bridge true knows no bounds. These megaprojects are just a glimpse into their engineering prowess. Know any other mind-blowing project?